Huh? What?
Hello everyone, we are with North Carolina A&T State University. My name is Asha Patrick.
I'm Tiffany Smith.
I'm Javon Rustin.
I'm Camille Sherrill.
And I'm Donovan Sweet, and we will be teaching you Quicksort.
Quicksort is a fast sorting algorithm with an average running time of n log of n and a worst case running time of n squared. There's a 3-step process for Quicksort. The first step is to partition the array into 2 different arrays. The second step is to sort the 2 arrays by making recursive calls to Quicksort. And the third step is to combine, but since the arrays are already sorted, there is no need to combine.
The quicksort method passes in the parameters A, P, and R. A is the array, P is the first position of the array, and R is the last position of the array. The if statement, if P is less than R, that ensures that P and R do not equal each other and that there are more than one element in the array. To give a value to Q, we use the partition method. That returns a pivot number. From there, we go do the quicksort method again. This quicksort method does the quicksort for the beginning of the array to one position before the pivot point that you found in the partition method. In the second quicksort, we'll do a quicksort for one after the pivot point to the end of the array.
In the partition method, you will pass the array P and R. P acts as the first position of the array, R acts as the last position of the array. You start with a variable and assign it equal to the last position of the array. Then you set another variable equal to the position right before the first position of the array. So I'll be right here. Then you have a for loop which sets J equal to P, the first position of the array. And it's going to go into the last position of the array. Now, if J is less than the last position in the array, then you're going to increment I. You will increment I and set I equal to J. You would just switch I and J. But since it's not, I'm not going to do that right here. So, if it's not greater than the last position, it's not less than the last position, then you would just increment J. So you increment J until you find a number less than the last position. In which case you would increment I and switch I and J. So now 1 will be here, 4 will be here. After you've done that for every position, you then switch the last position with position I plus 1. So that means that you can switch this position and 2 would be here, 5 would be here. Now the goal for this is to get everything that is less than the last position of the array all on the left side, and everything that is greater than the last position of the array all on the right side. That way, when the quicksort method is called again, it will just have to sort everything on the left side and everything on the right side, and the pivot will already be in order.
I will be explaining an example of quicksort. First, I will assign P to the first position in the array. Next, I will assign X to the last position in the array. I will be the position prior to P, and J will be equal to P. We first begin by comparing J to our X. We see that our J is less than our X, so we increment our I, and we would switch J with I, but since they're the same number, we won't. Next, we increment our J. We see that 7 is greater than 4, so we won't increment our I. We increment J again. Once again, 5 is greater than 4, so we won't move our I. Increment J. J is now 6, which is still greater than 4, so we still don't move our I. Increment J once again, and we see that 3 is less than 4. So we increment our I to 7, and then we switch our J and our I. Next, we increment our J once again. And now we see that 9 is greater than 4, so we don't increment I. We increment J. 2 is less than 4, so we increment I and switch our I and our J. position before our last position, so we will now switch our X with our I plus 1. Our partitioned array will now read
We now divide into the array into two subsets around the pivot point. The P to Q minus 1 and the Q plus 1 to R. And now we must partition each side. One is less than 2, so we move I, and since it's the first position, we do nothing. We compare it to the second number, so as J increments, it is greater than, so we do not swap it. And so we reach the number before it, so we switch I plus 1 and our current Q, R, for the subset. So it becomes 1, 2, 3. And now we partition this, but since 1 and 3 are by themselves, you do not partition and divide them, they just get passed through and returned. And now I will partition the second subset. Seven is greater, so it just increments, J increments. 9 is greater than 6, so it increments. 5 is less than, so we move I, switch I with J, so it becomes 5 and 7. And now since we were right before it, we switch R with I plus 1, so it becomes 6 and 9. So now we partition the lower subset, which since it's a single number, it automatically finishes. And now we partition this side. Since it's less than, it increments. We do increments, and we do nothing, and then it terminates. So at the very finish, you get a number of 1, 2, 3, 4, 5, 6, 7, 9 as your array, your fully quick-sorted array.
A good example for quicksort would be, say you're a coach and you're trying to choose a basketball team, right? So you have this one player who, he was probably on the team last year, and he's like your average for making a team. He's the bare minimum. So he's gonna be like, you want people that are better than him, and you want people that are worse than him you want them to go home. So you have all these people over here that are better than this guy. You have all these people over here that are worse than this guy. So you have all the bad people over here. This guy right here, he's going to be considered your pivot. So all the garbage basketball players are over here, and you decide, oh, I need some more people on my team. So you want to weed out the good people, well, the best people out of the garbage people over here. So you choose another pivot. Now this guy, he's the bare minimum of the best of the garbage. So you want everybody that's up here to go ahead and join the team. You want everybody up here, get the packing. So you also want to sort out your good people, because you want to figure out who your starters are going to be. This right here is the pivot guy for your starters. The bare minimum of making a starter. Everybody up here, your starters. Everybody down here, they just made the team, bench warmers.
Quicksort is used because it has the best average case runtime. It is a combination of merge sort and selection sort. Once again, my name is Asha Patrick.
I'm Tiffany Smith,
I'm Javon Rustin.
I'm Camille Sherrill.
And I'm Donovan Sweet.
and this was Quicksort.